Hello, beautiful people. Today we're going to be taking some notes on combining like terms, and we're going to go into the distributive property and how the distributive property is almost similar to combining like terms, or we use combining like terms in the distributive property. So we're going to start out with example number one. And example number one is an expression. Now, an expression is a statement without an equal sign. You're going to notice that it's just a bunch of different terms, but no equals. Because there is no equal sign, there's nothing for us to solve, but we can simplify this expression until we basically can't simplify it anymore until we're all done combining like terms. So the first thing you need to do is you need to put bubbles, or I like to call them bubbles, around your like terms. So which terms are the same? So you're looking at the similar or the same quantity of variables, letters, or you're looking at no letters. So for example, I have a 4 and I have a -7. Now, notice that I took the sign in front of my number. So my sign in front of my number. Now this doesn't really have a sign in front of 4, but that's because mathematicians are secretly very lazy and they kind of don't want to write a plus here. So they just don't do it, but there's secretly a plus there. 7, then the symbol in front of 7 is this minus. And then what we're left over here is a -9m. Remember, m letter, that's a variable, and we're always taking the sign in front of it. So I'm going to go ahead and draw this out kind of how it looks like. So my 4 here means that I have 4 pluses. So I have 1, 2, 3, 4 pluses. My 9m are negative. Remember, we're taking that sign in front of it. So I have -9m's. So -1m, -2m, -3m, -4m, -5m, and 6m, and 7, and 8, and -9m. And then again, we're doing the same thing on, for the -7. So how many 7s do we have? How many negatives do we have? Well, we have 7 negatives. 1. Oops, excuse me. Let me erase them. We're just counting negatives. So we have 1, 2, 3, 4, 5, 6, 7. Now, here's the thing that we need to recall. Okay, this is super duper important to recall. A negative and a positive, this right here together, it makes 0. So anytime you have a negative and a positive, that creates a 0. That's nothing. So I have a positive and a negative. So what does one positive and one negative make? It makes a 0. So they go away. Again, one negative, one positive goes away. One negative, one positive goes away. One positive, one negative goes away. After you have created your 0 pairs, so we're going to call these 0 pairs, we're going to count what's left over. So I did not combine my positives with my -m because they have to be the same thing, okay? Either they're positive or negative. The only thing that would cancel out with my -m would be a positive m. It has to be the same thing. All right, so let's count what's left over. I have 1, 2, 3 negatives left over. So I have -3. Remember, you're always putting that sign in front of the quantity, in front of the number. And then I'm looking at how many m's do I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 m's. So 9 m's. And what's the sign in front of them? It's a negative. So this expression that we started with simplifies to -9m minus 3. Okay, let's try another example. So example 2. And let's do something a little bit more complicated in my opinion. Let's try, I don't know. Let's try k plus 4 plus 6k minus 1 plus 7v plus 8s minus 3v's. That's super duper complicated. I did that on purpose. But the steps are the same. First step is to put boxes or bubbles around the like terms. So I'm going to start with k. So all of my other terms with a k get a box as well. Remember, you're always taking the sign that's in front of the number. I don't have any more k's. So now I'm going to do circles. So my 4 has no letter next to it. So I'm looking for numbers, no letters. Okay, then I'm going to put a little cloud around my positive 70. Again, make sure you're taking that sign with it. And I'm looking for V's. There's another V. Make sure you're taking that sign with it. And then I'm left over with my positive 8s. And again, sign goes in front of it. We're going to do exactly the same thing we did. We're going to draw what we have. This one right here, mathematicians are what? Lazy. So even though it doesn't have a number out in front, this number is 1, positive 1. So how many k's do I have here? I have 1k that's positive, so 1k that's positive. I have 4 pluses, 1, 2, 3, 4. I have 6 k's that are pluses, so 1, 2, 3, 4, 5, and 6. I have 1 negative. I have 7 V's that are positive. 1, 2, 3, 4, 5, 6, 7. If you want, you can put your pluses in front of them. I have 8 S's that are positive. 1, 2, 3, 4, 5, 6, 7, 8. And I have negative 3 V's. Again, how many V's do I have? I have 1, 2, 3. What's the sign in front of them? They are negative. Now is where we make our zero pairs, or we combine our pluses and minuses. Remember, they have to be the same. So if it's a plus k, it has to be a minus k. If it's a plus v, it has to be a minus v. If it's a plus, it has to be a minus. The letter must match up. So let's start with k. Do I have any minus k's here? I know I have a k, but I don't have minus k, so we can't cancel anything out. I do have a plus. Do I only have a minus without any letter? Do you notice how there's no letters here? So in order to create a zero pair, it has to be either the same letter or no letters at all. So I'm going to combine this plus with this minus because this minus does not have a letter and this plus does not have a letter. So I'm going to create a zero pair, means that combining these two together will give me 0. Now, k's we already talked about. There are no negative k's for me to combine with, so I'm going to move on. I have a positive v. Do I have a minus v that I can combine and create a create a zero pair? Yes, I do. So I have 1 positive, 1 negative. That's a zero pair. 1 positive, 1 negative. That's a zero pair. 1 positive and 1 negative. That's a zero pair. S's. Do I have any negative S's to combine with? I do not. So once you've created all of your zero pairs, you're going to see what's left over. So how many K's do you have? I have 1, 2, 3, 4, 5, 6, 7 K's. I have 1, 2, 3 pluses. And I have 1, 2, 3, 4 V's. And I have 1, 2, 3, 4, 5, 6, 7, 8 S's. So this here, you have combined like terms, and this is your expression that you get at the end. Okay. Now, how does this compare to the distributive property? Whenever you think of distributive property, Let's do an example. So this is example number 4. Let's make it example number 1. So example number 1. Let's start out with something with pretty numbers. We like pretty numbers. 2 is a pretty number in my opinion. 2, and then we have parentheses. Let's try 3x plus 5. Okay. Whenever you think of distributive property, most of the time what you see, get a different marker, most of the time what you see is you see arrows. You see something like this. And before we even start doing things with arrows, I want to talk to you about what it means to have something in this form. Okay, so I'm going to rewrite it. I'm just going to move it over. I have 2 and then in parentheses 3x plus 5. Ooh, that 3 looks a little weird. Don't mind that. This is 2 times 3. Let's see if I can remember how to spell 3. 3x plus 5. So again, mathematicians are lazy. So because we are so lazy, there's a multiplication symbol right there that we are really lazy and we don't want to write. But it's there. Anytime you have a number in parentheses, anytime you have parentheses and there is no symbol, that means multiply. That means multiplication. Same thing here. See how there's a number and an x, but there's nothing in between it? Well, that just means multiply. That just means multiply. Okay, let's go back to our combining like terms. This is combining like terms. In our combining like terms, whenever we had, let's do this one, 6k, we had 6k's, the quantity, we had 6k, so we drew 6k's. Now again, mathematicians are very lazy, so because they are so lazy, there's a secret multiplication in there, there's a secret dot there that mathematicians just don't write because it takes time, it takes too much time, so they don't do it. But this is, I have 6 groups of k. So 1, 2, 3, 4, 5, 6. Okay. Similarly, or the same way, we're going to translate this to say I have 2 groups of 3x plus 5. So what that means is you're going to say, since I have 2 groups of 3x plus 5, that means I have 3x plus 5 and I have 3x plus 5. Now, let's do what we did with combining like terms. Let's translate this. Okay, so let's see here. Here's a bubble, 3x. And I'm going to look right here in the same line. Do I have any other 3x's? Yes, I do. They're right here. And then 5. I'm going to put these here. Okay. All right. Let's draw this. 3 x's, right? I have 3 x's. 1, 2, 3. I have 5 pluses. Again, it's the sign and always in front of it. So 1, 2, 3, 4, 5. Again, we have the same thing twice. I'm going to copy and paste this here. So I have 3 x's and I have 5 pluses. 1, 2, 3, 4, 5. There you go. And then you're going to combine like terms. So what's the total? Do we have any 0 pairs? Do we have any pluses or minuses that need to cancel out? Well, let's check. Okay, I have 1, 2, 3, 4, 5, 6 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pluses. And you have now simplified. You have now simplified this mathematical expression to 6x plus 10. Now the reason you see teachers doing this is because if you have really big numbers, drawing them out becomes very tedious, or it just takes a lot of time, to be honest. So what teachers do is, again, mathematicians are lazy, right? So we created a little cheater way of doing it. It's called the distributive property. So you are distributing that number out in front into the parentheses. So you are saying, remember, mathematicians are lazy, so there is a dot here. There is a multiplication there. So you're saying 2 times 3x, 2 times 3x, and, remember, plus is and, 2 times 5. Again, 2 times 3x, 2 times positive 5. So then, what's 2 times 3x? If I have 2 groups, here's one group, here's 2 groups of 3x, I got 6x. And if I have 2 groups of 5 positives, I'm going to get a total of 10 positives. And you have what you've got here. Okay. Let's try another one. Example 2. All right. Let's try another pretty number. 3 times 1 minus 9x. Now this is going to be a little bit more difficult. Okay, I'm telling you right away, it's going to be a little bit more difficult. Let's translate that. We have 2 groups. Ooh, I'm already making mistakes. How many groups do we have? This number tells you how many groups. So I have 3 groups of 1 minus 9x. So that means I have 1 minus 9x, and I have 1 minus 9x, and I have 1 minus 9x. I have 3 of them. So again, like terms, all my 1s are going in a bubble. So 1. Now that looks like an 11. Bear with me, you guys. Okay, and all of my negative 9x's are going to go in a bubble. So I have, remember, mathematicians are lazy. If you don't have a sign in front of it, that means it's a positive. So I have 1 positive, 1 positive, 1 plus. Then I have 9 x's that are negative. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 9 x's that are negative as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So after you're done with all of this, then you get to combine like terms, count what you have. Okay. So I have 3 pluses. So 3 pluses. And then how many total x's do you have? First of all, is there any 0 pairs? Is there any positive x's or negative x's that you can combine? I only see negative x's. I don't see positive x's, so there are no 0 terms. So we just need to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have negative 27 x's. Now again, mathematicians are lazy, so you will not see them write that plus out in front, so I'm going to erase it. And then you have simplified your expression. Now I'm going to show you the other way. Okay, the other way. Once again, you're usually going to see arrows when you do it this way. Arrows this way, arrows this way. All right, so 3 times 1 and 3 times negative 9x. Again, you always take the sign that's in front. Always, always, always. Okay, so 3 times 1 is 3. 3 times negative 9 is negative 27x. Now, again, mathematicians are lazy, so when you have and a negative, you're usually going to see it as 3 negative 27 or 3 minus 27x, and it matches. So the reason we like distributive property is because it saves us a lot of time and effort. We don't need to draw these out, add them together. I hope this has definitely been helpful. If you have any questions or if you noticed a mistake, please let me know. I would definitely love to fix any mistakes if you notice any mistakes. That way we can both learn from them. Again, let me know if you have any questions. Thank you for watching.